Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
Hi students, today we are going to discuss a very important problem. Take down this problem. A rectangular conductor LMNO is placed in a uniform magnetic field of 0.5 Tesla. The field is directed perpendicular to the plane of the conductor. When the arm MN of length 20 centimeter is moved towards left with a velocity of 10 meter per second, calculate the induced EMF in the arm. Given the resistance of the arm to be 5 ohms, assuming that the other arms are of negligible resistance. Find the value of current in the arm. So this question has been asked in 2013. Let me explain about this problem. See, the X marks are given. These X marks are representing the magnetic lines traveling inward vertically to the plane of the paper or this board or screen. So it will be traveling like this. Okay, right. And you got the metal rod MN. This is a metal rod. And you got the frame LMNO. LMNO. It is given here. And it is placed in a uniform magnetic field. So we have got already this inward magnetic field that is perpendicular 0.5 Tesla. Right. The field is directed as I already explained. So this is the conductor. Now field is in this way. So 90 degree. Okay. Right. Now the MN, that thick rod, it is represented as a bold dark line, thick rod. That is MN and its length is 20 centimeter. Now this is moved left, that is moved left with the velocity. So that velocity is 10 meter per second. We already know when a metal rod is moved in magnetic field, there arises two kinds of forces. One is the Lorentz force, the motional, that is responsible for the motional EMF. So Lorentz force and the Coulombic force. So these two are very, very important here. So that what happens, these free electrons will be moving downward to, upward to M. Okay, if it is moving right side, downward, moving left side means upward. So there arises the potential difference, right? Now, the resistance of the arm is given as already 5 ohm. So we need to calculate how much current is induced here. Okay, so shall we proceed? So the EMF induced in the coil is given as E is equal to minus d phi by dt according to Faraday-Lenz law. That is rate of change of flux, and this EMF is opposing this change of flux, and that is why you have got the negative side. And this is E is equal to minus d phi by dt, and we have got already, that is phi is given by B into A, where cos theta, that is cos 0 is equal to 1. So we have to consider only BA in this case. So here let us consider phi which is nothing but BA, is it not? Phi is equal to the magnetic field, the magnitude of the magnetic field and the area enveloped by the coil or the conductor here. So we can replace this. E is equal to D of minus D of BA divided by dt. Got it? Right. And so you've got already this metal frame where you've got the moving rod here, MN. This is the MN. Okay, this is the moving rod. Now this makes an area. So it means what? The area is nothing but the area of the loop. That is the length into breadth. Is it not? L into B. Right? So here the length of the rod is L, and the movement can be called the width or breadth here. So L into X will put. So that is A. Do you understand? So we have got now the area. And now let us substitute. Phi E is equal to minus D of, and you have got already the magnitude of the magnetic field. Then area is nothing but L into X. Right? Whole divided by the rate of change, that is divided by dt. Okay? Right. Now, here the only variable is X, because this is the fixed quantity, constant B, constant magnetic field. L is also constant because length of the rod is constant. So the movement can be done, it is given as towards left. So the X alone is the variable. So you can retain this as constant. So you can bring out of differentiation. Therefore, E is equal to, that is minus, and then BL into dx by dt. Do you have anything? Okay. So dl by dx by dt. Right. So this dx by dt, some displacement taking place in a given time is nothing but velocity, is it not? So the velocity of the loop we can say, because this is the rod and you have got the pear-shaped frame. So this will be varying. The area is varying because of the movement. So how fast it is moved here. Okay, so that is the velocity. So this velocity is nothing but the velocity of the electron traveling inside the rod, is it not? So E, and this can be called velocity. Okay. Therefore, we can call it E is equal to minus B L V. Okay. So this is the important formula you have to derive. Right. Now let us substitute what is given here. It is given as B is given how much? 0.5 Tesla. That is the magnetic field. And what about the length? 20 centimeter. Centi is 10 power minus 2. So 20 means 0.2 meter. So 0.2 meter. And then what is the velocity? That is 10 meter per second. So 10 meter per second. Right? So that is equal to what? E is given as 1 volt. You can ignore that negative. You can make it as a modulus value to attain the that is positive value. So induced EMF is 1 volt. It is given current in the arm. So how much is the current? That is I is given by, we can apply Ohm's law. E is equal to IR, is it not? So E by R. Understand? Now we have, that is E, how much? 1 volt divided by, what is the resistance given? 5 ohms resistance. So 5. Therefore, the current passing through, that is induced current, is 0.2 ampere. Okay. So likewise, you have to derive this equation. Okay.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.